guys. Let's make a video. Okay, let's go ahead and hit start. Let's see, do I have all my problems ready? Okay, we just need to loosen up one more time. Okay, let's do some math. This video is going to be great. The students are going to love it. They're going to learn. They're going to learn. Learn, students learn. Learn, students learn. All right, let's just hit the record button. Ooh. Looks like I was recording. Okay. Hey guys, welcome. Let's get started. 10-4 video coming at you. Here we go. So let's take note of this. Write this box down, please. And it says the perimeters and areas of similar figures. So we've talked about similar figures before. The scale factor of two similar figures would be A to B. Then we could go ahead and use that same ratio to compare perimeters. And the reason why we can use A to B to compare perimeters is because a perimeter is one dimension. It's just the distance. So distance is one dimension. So if I said, how far is my house from Disneyland? That's going to be, whatever, 30, 40 miles. That's one dimension. Versus area is two-dimensional. So when I say this side to this side, the perimeter is still the same ratio, A to B, one-dimensional, but the area is going to be A squared to B squared. So we have to square it because area is talking about two different dimensions. Okay? So we're going to use these two within this situation and see if we can learn some stuff about area and perimeter and how their ratios differ. So here we go. Let's take a look at our first problem. Dun, 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 dun. Okay, that was not that exciting. All right, the trapezoids at the right are similar. So these two are similar. They're told to us that they're similar. And it says the ratio of the lengths of the corresponding sides are 6 to 9 or 2/3, so they just reduced it. So my question is, if you could write this down, what is the ratio of their perimeters? Perimeters. And what is the ratio of their areas? Okay. So if we look back at our little fact, sorry about that. If we look at our little fact, we see that our ratio 2 to 3 for perimeter stays the same, so A to B. So we just still get 2 to 3. That did not change. But areas, since we're going to go ahead and find two dimensions, we need to square it. So this is going to be A squared to B squared, which means we're going to have 2 squared and 3 squared, which means we're going to have 4 over 9. So again, we're going to go back and forth between areas, perimeters, and side lengths, and we're going to use the appropriate way to go ahead and associate their approximate ratios. So let's go ahead and look at an example where we might actually use this. Name what movie that's from. Extra credit. Okay. That's rough because that sounded horrible. Here we go. The area, oops, gotta pause that. The area of the smaller rectangle is about 27.5 square centimeters. So we got this piece right here. Let's go ahead and write this down. Make sure you draw the pictures. The area is equal to 27.5. What is the best approximation for the area of the larger rectangle? Okay, so first of all, what is the scale factor? So let's go ahead and get the scale factor first. So scale factor we've talked about before. It's basically saying what is one side compared to the other side. We want to make sure that they are the corresponding pieces. So here we're going to go 4 corresponds with 10. So that's our scale factor. This we would call A over B. Now we're looking at area. So if I just went like this and said, oh, then this must be equal to the area on this side, and I did 27.5 on the top because that is associated with the 4, and x on the bottom, this would be the wrong equation. since we're dealing with area, we got to take the normal scale factor and we got to square it. Okay? So we're going to square this and square this and square this. There we go. And we'll go ahead and have the correct way. Again, it's not equal to a to b, it's equal to a squared and b squared. So let's go ahead and do a squared and b squared, which is going to be 16 over 100 should be equal. So now this is an area factor, right? Because this is a squared plus b squared, equal to 27.5 over x. And we're going to cross multiply. So we get 16x equals, now 100 means I moved the decimal over twice, if you guys remember. So that would be moved over once and twice. So if you don't believe me, you can check your calculator. Alright, and then we can divide by 16. Now this one, I don't have a fancy way of doing it in my head, so let's just double check it in our calculator, which I have right here. Okay, let's see here. Turn it on. Divide by 16. And we're going to get this fun decimal number. What's the best approximation? This would be our best approximation. And what I forgot is centimeters squared. There we go. Added it on at the end. Okay? So again, find the scale factor. Make sure it's dealing with areas. We're going to do a squared and b squared. And then we can go ahead and set up a proportion. All right? Moving forward, onward and upward to infinity and beyond. Wait. Oh, look at all those words. The numbers. Oh, this one's easier. Oh, wait, I didn't want to do this problem. Don't write it down. Scratch that. Oh, you're going to hate me. Sorry. I want to do this one. Alright, this is our last one. Last one, I promise. So hopefully you didn't write that last one down. Psych out if you did. Okay, triangles at the right are similar. What is the scale factor? What is the ratio of their perimeters? Okay, so we got three things going on. We got scale factor, we got perimeter, ratio, and then we got area, ratio. Okay, now scale factor, a to b, ratio, a to b, area, a squared to b squared. 2 dimensions for area, 1 dimension for perimeter, 1 dimension for scale factor. So the first two, 1 dimension, second one is 2 dimensions. All right, so a squared, b squared equals, now I'm going to put the smaller on top, 50 to 98. First thing I should do, scale factors are always simplified fractions. So looking at 50 to 98, can I reduce that? They're both divisible by 2, I know that. So half of 50 is 25. Half of 98, I believe, is 49. Let's double check. Can't believe I'm still sick. This is crazy. It is 49. Isn't that fun? Okay. So my question is, okay, so this is my area ratio, which is cool, but I want the scale factor and I want the perimeter, which both of these are the same. It's a to b and a to b. So how do we do this? Well, if I want to find a, I'm going to take the square root of a. And what's the square root of a? 5. So we get 5. Boom. Boom. And if I want b, I'm going to have to take the square root of b, which is 7. So 7 and 7. So those are your answers. Now again, scale factor and perimeter factor are going to be, scale factor and perimeter ratio are going to be actually the same because they're both a, b, and AB because they're one dimension, versus the area ratio is two dimension. Okay, so that's pretty much it. We're just talking about the difference between area and perimeter. All right, guys, thank you very much. Have a good one. Over and out.
So I think the stop sign is up here somewhere.